Hi, there we go. Thanks
All
for
right, we get a great
bearing
ring.
with us. Morning presentation, last day of the conference, you name it.
Yeah.
Cool. Hi everyone, my name's Oleg. I'll be talking about beyond detection, evaluating, test, fix flakiness. I work at Okta. Vincent, my co-author, and we created the CI quality enablement team at Okta, a team focused on building tools to enhance the visibility and reduce the friction of developer experience and bottlenecks to velocity. So thanks for having me. Let's begin. So we're going to cover how we expanded our flaky test mitigation systems. We introduced AI orchestrated fix attempts and how we are building a continuous self-healing feedback loop. I'll be talking about how we started evaluating the effectiveness of flaky test fixes and introduced agentic workflows to help deal with confronting these issues at scale. First, we'll discuss how we expanded our test flakiness mitigation system two ways. We included the automatic first fix attempt for AI, for flaky tests using AI to drastically reduce the impact of flaky tests. Also, the burden that on-call engineers face dealing with flaky tests. Second, how we added a post-fix evaluation step into the tooling. So setting the stage, we have a robust flaky test detection system. We have processes adhered to by all teams with established SLAs. Just realized that you can't see.
It's cut off, right?
Cut off.
Yeah, I will.
I think the issue is like the resolution of the screen. I'll just present it for my laptop.
Yeah, but it might still be an issue, so I mean,
Okay. Oh yeah. Ooh, perfect. Thank you. That works.
let me just check that like people are still seeing it.
Thanks.
Yeah, it should. So
Thank you so much. Technical difficulties dealing. So anyway, we have a robust flaky test detection system. We have processes adhered by all teams to detect these. We measured how teams resolve the issues, applying test fixes, or they defer these fixes to meet their SLAs, their stringent SLAs. What we don't have is the evaluation of the effectiveness. Of flaky test fixes. Data-driven insights about the effective versus not so effective fixes. And we also don't necessarily, and we also need to explore how to alleviate the burden of on-call engineers dealing with flaky and failing tests. So to set the stage, we'll talk about our target code base will be the monolith. We're talking about 210,000 tests with a 14% year-over-year increase in our target example. We've built integrated tooling, auto guardian and auto exclusion that works to detect, exclude, and alert test owners when tests reach a target flakiness threshold within our CI system. We've also expanded our tooling by introducing Flake Refryer to conduct continuous evaluation audits of the quality of the fixes and the effectiveness of the fixes when they are applied. So we integrated Flake Refryer to support expedited refiling of flaky test tickets by Auto Guardian and the unblocking of developer merges who are blocked or interrupted by flaky tests. So Octo is an agent that acts autonomously to support software engineering tasks at Octo or at Okta. We were the first team to onboard and integrate the high-scale workloads to Okto within the company. Within the first month, we were able to resolve over 40% of our filed flaky tests and failing test tickets by the autonomous AI agent. So today, we're continuing to play a pivotal role resolving this and serve some good data points for the company on autonomous agentic usage. So we'll look into the life cycle by fast forwarding to when a ticket is slated to be created by AutoGuardian. Octo is enabled if the code base is orchestrated for asynchronous agentic software development workflows. Once Octo achieves a result, we transition the ticket and alert auto on-call guardians to finish resolving the ticket. And that means a PR is fully ready for merge. It passed dev, it passed CI, and it's pretty much a one-click experience. As the ticket gets resolved, we also do evaluate whether or not the PR metadata is actually used. The PR that is raised by Octo is used in the actual resolution of the Flaky test ticket. So do we actually use the PRs or do we trash it? Okay. So there we go. We worked closely together with the Octo product quality team to converge several knowledge bases together. We had curated guidance on creating high quality tests alongside curated snippets of code to enable good coding and testing practices across the test layers and samples of effective Flaky test fixes for different themes of errors. So this was all manually derived before the introduction of LLMs broadly in our corporation. So separately, we evaluated a data set of a golden list of effective test fixes across various test types. This led to the creation of the Flaky test skill, which enabled agentic capabilities from the get-go. So converging these two starting sets together allowed us to reason about how we would incorporate autonomous agentic workflows to resolve Flaky test fixes. Okay, let's do 2 slides. So agentic orchestration of the code base after the creation of the Flaky test skill allowed for the engineers to use it during incremental development, but also we were able to piggyback off it for agentic workflows. So this was a fantastic unlock. We had happier on-call guardians, we had faster time to resolution, we had that AI-assisted first pass of a Flaky test fix with PR fully ready to be merged. We still had humans in the loop, and we also generated AI learnings with every PR that Octo raised for subsequent tuning, refinement, and cleaning. As we extended, or rather, an extended team spent a lot of effort ensuring that Octo had a bunch of enterprise-level guardrails, security controls, budget constraints, kind of rigid constraints to actions within the allowed tools and iterative sequence of steps. So we iterated on budgets. Initially, we started at like 50 cents or whatever for the triage stage. We had to elevate that to a couple bucks, realizing that some things were a little bit more difficult. We also had to modify the models that we use and so forth. Another one was ideating how to actually transition the tickets during Octo agentic failure states. Do they go in progress? Do they go to pending review? Do they go to blocked? And how do we get people to actually realize that they should be reviewing these agentic generated PRs efficiently, right? This is a net new workspace for everyone. So we're tying it all together. When a test is deemed flaky, we have a control flow flag that determines whether the agentic workflow will be looped into or stepped into. If it's enabled, we pass some parameters around the Flaky test to be consumed alongside it, such as test type, the failure stack trace initially, and then we tag the ticket to ensure that obviously we only enter the agentic workflow once. We do permit for multiple retries based on failed compilation errors or failed CI. So Once everything is green, passes local dev, CI dev, we update that, we update that ticket to developers. So this is where Flaky Fryer, the actual evaluation of the Flaky test tickets come in. After some Flaky test ticket is merged, we wait an established buffer period, and then we initiate an observation period to get an initial evaluation result. We establish 3 final states for an evaluation: effective, partial, ineffective. Effective means no failures. Partial means, it's greater than 50% test stabilization over the baseline, and effective less than that. So Flaky Fryer runs consistently. It updates the ticket with the most recent score, allowing AutoGuardian to actually make the workflow decisions. So it's a completely, separate ad hoc process. Now, the baseline period is associated with when the ticket in question got filed. We know exactly the attributed flakiness and failure statistics. We conducted a retrospective analysis of the resolved tickets from past data to identify how much time we need to wait to achieve an accurate enough evaluation. And that became our fixed observation period during the past couple of months. We haven't fine-tuned it thus far. So AutoGuardian is tied to this. It will make workflow decisions if flakiness persists. So if an attempted fix is evaluated as partially effective or ineffective, on the subsequent time that our AutoGuardian notices that a threshold gets hit, we are able to log Flaky test tickets 50% quicker than before we had this evaluation system in place. So every code base and metrics database may be different. So we settled on, if it's accurate enough, if it's accurate enough, we would err on the side of caution, and we will file another ticket for the agentic workflow to be evaluated for Flaky tests. Right. Now, what do we do with stale evaluations? As the system does run continuously, we pretty much keep the latest one. It's always a net new. And then how do we use evaluations to improve our agentic enabled workflow decisions? So we started to tag and decorate our Flaky test tickets with learnings of what was effective, what was ineffective in the Flaky test ticket itself, to allow for the agent to better reason about what test fixes to suggest and what not to suggest, right? So now recall that octo-generated PRs, we add some, agent learnings to an output directory that's referenced for subsequent tasks. We search for relevant lessons and append this data to the AutoGuardian generated tickets, as I discussed, and then the tickets are decorated with some of these information, with some of this metadata. Sorry about that. So, we have all the data. Our code base is hooked up to with a code generation harness, and we pass all the Flaky test tickets into the autonomous agentic first pass fix attempt. Now, if a flakiness threshold is hit, a new round of auto triage happens. We now believe that filing Flaky test tickets is way less painful and way less friction-inducing to on-call engineers. So because we do offer the capability for on-call engineers to have that one-click, merge the fix, we are comfortable filing more tickets than we would because as we believe the burden is not as high as it used to be for on-call. So we're early, but we believe that there is a virtuous self-improving cycle in this sort of compilations of data that we provide to the context. So where do we go from here? We're investigating creating a Flaky test fixing harness as more and more teams want to explore those capabilities. So we want to get ahead of the demand, and we want to supply some sort of framework that allows teams to, plug in maybe their code base with what we believe is safe Flaky test fixes. The Octa platform obviously supports a lot of other code bases, or a lot of other code bases, but also other operating systems, devices, browsers, third-party testing tools. So we're trying to figure out how we can possibly integrate these into those third-party tools as well. And of that note, we're thinking about how to avoid waste, reuse investment, reuse tooling, and all of the other capabilities that we've kind of achieved with that first-class citizen for us. There are cases that we've had to delete agent learnings from ineffective fixes. We are trying to figure out how to do that scalably, because we can generate a bunch of data that seems right and it gets merged into the agent learnings, but the code base is probably not the right place for that data to live. So, it's a active problem that I think we're trying to think about right now. For points 3 and 4, as the evaluations occur after the learnings, we have to observe the post-fix attempt. So we have a time issue when it comes to, we're trying to figure out if something's ineffective, how do we get that ineffective recommendations out of the system? We are assessing what circumstances teams don't use Octo and don't use the suggested Flaky test fixes, and why. So going from there. So thanks for listening. I hope you found several takeaways available for questions, and your suggestions on improving our efforts where we are now. Thank you so much.
Question, does this work? Cool. So, awesome work. Flaky tests are like the beta of our existences. I'm wondering, how do you know whether it's a test flaky, whether a test is flaky because the test environment is flaky, because the test is flaky, or because the product is flaky? Because it sounds like you're fixing the test, but it could be, there's sort of 3 main root causes.
You're right. So we broadly, I would say we exclude infrastructure issues just in our test, in our Flaky test, in AutoGuarded. So if it's an infrastructure issue, we try quite hard to not bug teams with it, and we have that baseline layer. If it is a product bug, this is where we assign it to the home teams, to the product area teams, and we do expect their level of introspection a little bit. But I do concur that if it's so easy to generate a fix, can there be adverse impacts on, or less investigations on, a real product issue? And that is something that we will be considering in the future.
Yeah.
Well, I also talk. Could you say a little bit more about any data you have on how often the PRs, it sounds like they're not automatically merged, or rejected by the humans? Like, what's the take-up rate? And it sounds like also that maybe you haven't deployed it like company-wide yet. It's still like sort of in, I guess, like a pilot and on like internally for the CI group. Did I understand that right?
It's company-wide deployed for our first-class support for Flaky test management. So that is deployed, but from a perspective, I would say roughly it seems like 40 to 56% of PRs do have Octo as a starting point for the Flaky test fixes. Do developers make changes to it? We don't look at that. We have not looked at that yet. So what about the other, the other half? Is it because we don't have a good enough like a human process that is orchestrating all of this, that people are still trying to fix it locally? Or is it because we are not doing a great job of notifying them that something is ready? The the notifications, the feedback is quite quick. Like within 20 minutes to an hour, you have a PR that's ready to merge on the base case. So that's faster than most humans will be able to get to a ticket that they get assigned fundamentally. So why don't they use it? I don't know.
And have you gotten any feedback from product teams, positive, negative, indifferent? Like what has been the feedback from people who are subject to like receiving these PRs? Do you know?
I think positive. And at the end of the day, they would still get these tickets sent to their team. So their teams would still have to file them. So we are not necessarily, we don't think we're creating more tickets. We don't think we're creating more work. If anything, we're making it easy for them, possibly too easy for them. But the sentiment, I think, has been positive for most people.
And have you determined a way to estimate like the return on investment or like business value of doing this? I think this is like something that I'm interested in. New ideas on.
It's cheap. So it's cheaper than any engineering time. Right. I think the costs vary between I feel like $2 and some change to possibly I've seen $12. And obviously this was a pilot project, spurred us by our company. So we will find efficiency gains eventually, or we are looking at the cost as well. But $12 is pretty good for maybe saving a couple hours time, and even from the CI system, because when a ticket is uncovered and it's blocking, obviously that test is not run for developers to prevent friction, and so yeah, it's possible. I think it's possible.
Okay, so you would as like beyond the token cost, you're viewing it as like the number or like the amount of time that you're not blocking the product team due to a CI failure.
Yeah, so we're also, and there's that. We're also evaluating. There have been instances where teams are out of SLA to resolve these flaky test tickets. They do get. I think we give a 3-day SLA, 3 business day SLA for flaky test tickets to be resolved by teams. So there have been times where teams take way longer than that, and ideally that should drop very starkly.
Thank you.
Cool.
Sorry for asking too many follow-up questions.
Great question.
That's all right. We
Yeah.
have time. Yeah.
Thanks, Martin.
That's a very interesting topic, right? So this is a very interesting topic. So my question is like here we are just focus on like detecting like it is right. So do you have any ongoing work like for like preventing also, and on the other end like to like support debugging or fixing flakiness in an efficient way? Just curious.
Right. So we are. I mean, our goal is, because we are evaluating flaky test fixes, ideally effective flaky test fixes would go up, because we are actively evaluating it. So technically one can say that we are reducing flakiness in the system from that indirectly. And then you had another point that I think I missed.
So is there any kind of ongoing work to like have people debugging the flakiness?
Debug these octo-generated PRs, or debug.
The flaky issue. Where are they coming from?
Oh, yeah. Separately, but not associated with this. I think we are trying to figure out how to, how to group failures between team-specific failures to product-specific failures to, flakiness-specific failures. So we do have a way that, we do have a way that we are trying to measure the reduction of flakiness, but the data hasn't hit yet. This has only been, I think, 2.5 months in the making, I would say.
Hey, great talk. Yeah, I was wondering if you could talk a little bit more about, I like that you're using this sort of relevant learnings, in the process of, as an input for your agent. I guess, could you talk a little bit about that? And
Yeah.
any engineering challenges?
Well, because it's generated by AI, right? We think it's relevant. So we associate, and this is where Vince has been doing a lot of the work. We associate what is it? Root cause hypothesis in the proposed fix plan alongside effective test fixes and ineffective test fixes that are related in that similar domain. So we just smash that data into the agentic loop, and we are trying to evaluate whether it's using it effectively, and if there's too much context, and if we're giving it too much. So we're trying to figure out where to go from here about making sure that we don't overload, we don't give too much information that's kind of not relevant, right?
Yeah.
Yeah.
Yeah, that's great. I'd love to talk to you more about that.
Thanks. Any other questions?
So now we have AI being tested. Should we worry about testing the tests? So I can remove flakiness by removing an assert, but maybe that's an assert that would have found the bug, right? So I'm a little paranoid about how do we test the tests?
Yeah. I would say, so this is where so we were looking at, so initially in the paper, we were looking at 121 fixes that across the testing pyramid that were effective across different testing types, across different run types. So we did inject some reasoning about what not to do, what Flaky test fix should not do. Like, it should not quarantine a test. It should not remove an assert. So we do have that explicitly baked in. And I guess the PR is the final gate that allows people to, that requires people to really, have critical thinking about whether this is good or bad. Because if you provide folks, green build, green CI, merge, I hope that people still use critical thinking in ensuring that the test is still valid and it's still doing the thing it has to be. But that's like a human problem that I feel like technological systems are not that good at, setting that up. Cool.
Thanks for the talk. This is a great topic. One of the things that I noticed that you mentioned that 40% of things were fixed. So this is great because when you got a fix, you probably can identify the category of the flaky failure.
Yep.
So I wonder, what were the most common categories in the tests that were actually like flaky tests that were fixed?
Synchronization issues for both for end-to-end UI tests and even API tests. Like jobs processing in the background, like faulty test design that did not wait for some job to process in order for the test to run successfully. That was like for the the non-UI test, let's say. And then for UI test, it was just, poorly designed or lack of transition assertions. Yeah.
Then I'll have one follow-up question when it comes to the fixed skill. Was the fixed skill like pretty open-ended that allowed the agent to explore, learn about the code base and then create the fix, or rather it was like enumeration-based, where the agent was just like relentlessly trying many things in the loop?
It was not relentless. I think it was quite structured about what's the stack trace, what theme of error is the stack trace, what's the test type, have you seen this? It's like, have you seen this before? So kind of once it did that structured increment, sequential approach, then it would, I think, start reasoning about the test, and if it compiles, and if it follows the rules that we constrained it on, then that's where we kind of proceeded to the next step, the next phase.
So that means that you did rely on like agent getting a deeper understanding of the code base and the.
Yes, yeah. It was YOLOing around the code base.
Are you able to share what base cell you used and if you did any fine tuning or just context based?
Context-based, a mixture of, a mixture of haiku and sonnet. Cool. Thank you, everyone.
Thank you so much, Oleg. We can bring in this other from. Over the back here.
Oh, sure.